Hello students, I urge you to watch my previous video on resolution of forces. Here we are going to resolve the forces along the inclined plane and along a plane that is perpendicular to this inclined plane. Now before we do that, you need to know something. You need to know that if there are two lines which are making angle, say alpha, between them, then if you draw perpendiculars to these lines, that means you draw perpendicular to, let's say this is a b and c. If you draw perpendicular to ab and if you draw perpendicular to ac, right, then the angle, this angle, I would draw it. This angle is also alpha. Now that is something which can be proved, and I leave it to you. So two planes or two lines, if they make an angle alpha, then perpendiculars drawn to them at the intersecting points, these two perpendiculars also make the same angle alpha. Now that you can be proved, and I leave it to you to prove. Just geometrical construction, you will do that. Okay, so this is something which you will remember. Now see, here we have a inclined plane, a horizontal plane, and let's say the angle, will take angle, say alpha. These two planes make angle alpha. On the inclined plane there is a box, there is a weight placed. Let's say that mass of this is m, then this is m kg, right? This is the mass. So if this is the mass, then the weight will be m into g. Now let's show all the forces. The box has weight, and because of that weight, the weight will of course be acting downwards because the earth is pulling the block, and that is weight, gravitational force. So that is this, and this is m into g, right? Mass is m, so the weight will be m into g, right? And since the block is placed on an inclined plane, plane will have a reaction, right? So the weight is of course borne by the inclined plane. So as a reaction to that, the inclined plane, will give a reaction, and that we call it as normal, and it's normal to the inclined plane. So that is, sorry, that is going to be, this is mg, and this, I'll choose some other color. Let's say this is normal. I'm just showing this direction, so it's normal upward, right? And I can remove this. Okay, fine. So now see, as I said, the angle between these two. Now here I would like to extend this angle, just I explained to you right at the beginning, is also alpha, because these are, mg is perpendicular to the horizontal plane, right? Mg is perpendicular to this, the horizontal plane, to this mg is perpendicular, and this n is perpendicular to the inclined plane. So the angle between them is alpha. Okay, now the block, right now it is shown stationary. So obviously there is, the weight is, there is a component of the weight which will be along the inclined plane, and that would be pulling the block down. But the block is held stationary, that means there is some resistance, so that is friction, right? This is friction. Now let's resolve the force. Let's this is under equilibrium, so let's write down the equations. Sigma fx is equal to 0 and sigma fy is equal to 0. But for that, let's find out let's resolve the weight mg, right? We'll resolve this weight mg along the inclined plane and perpendicular to the inclined plane, right? So basically we are considering this x-axis as along the inclined plane, and y is along the plane which is the plane perpendicular to the inclined plane, so along normal n, right? So this is, I should have written this as y. This is y, x and y. Okay, so if we want to find out, we want to resolve the force mg along x direction. Okay, now I want to invoke the earlier video, not first, earlier video, where I gave you steps. Step number 1 is, if you want to resolve the force, first consider what is the angle the force is making with x-axis, and choose the smaller of the angle. For example, here mg, it is making with x-axis, means this inclined plane, right? This is our inclined plane. This is the inclined plane. So what is the angle mg is making with inclined plane? It is making this angle, and it is also making another angle, which I will show in green color. So it is making this angle, right, with the x-axis. So how much is this blue thing? This is obviously 90. This is alpha. So this angle will be 180 minus 90 plus alpha. So this will be 90 minus alpha, right? So this angle is 90 minus alpha, and remaining angle, this is the one which I have shown by green color, is this. This is a larger angle. And if you remember my previous video, I said you should always consider the smaller angle which the force makes with x-axis. So we are going to consider 90 minus alpha. Now our task becomes simple. We say that if you want to resolve this weight, I'll call W weight, in x direction, right? Then, or I'll say that which is mgx basically. So this is mg in x direction. Then this will be the mg into cos of 90 minus alpha, right? Because smaller angle is 90 minus alpha. So this will be mg cos of 90 minus alpha. Now you know what is 90 minus cos of 90 minus alpha? Sine 90 minus alpha. Sine alpha. So it is going to be mg sine alpha. Now what about the y component, right? So mg, let's say y. This is mg. As I said, same angle we are going to consider, but we will say sine of that. That means it is mg sine of 90 minus alpha, and you know this is mg cos alpha. Okay, now these are the magnitudes. Now the directions, you have to give the sign for that. That you can do when you are writing the equation. For example, mgx, that means this will be mgx. I will use this. I'll remove this. So this is, let's say, mgx, and this we have said is mg sine alpha. It's towards left, right? And so you'll take negative when you write the equation. Similarly, mgy, this I'm talking, when I say mgy, I'm saying this. That means the component of mg along the perpendicular to the inclined plane. So along this, this is along this, right? And we are saying that this is mg sine alpha. And then you will write, because the block is stationary under equilibrium, then you will say, we'll write sigma fx is equal to 0, which means this is F is frictional force I have shown acting towards right, because the block would move towards downward, so friction will be upward, and that is towards positive x. So we'll say F is positive minus mg sine alpha, and that is equal to 0, right? And sigma fy is equal to 0. So this will be equal to 0. That means it will be n, y is this direction, okay? This is y direction. This is your y direction. So we are n normal, which we have shown, is along positive y. So we'll write n, I should continue using n minus, now you'll write downward the mg component, which is acting perpendicular to the inclined plane, and in downward this is mg sine alpha. So we'll say give minus sign to this. Am I right? Oh, sorry, this is mg cos alpha, right? I'm so sorry for this. This was my mistake. This is mg cos alpha. So this will be n minus mg cos alpha, right? Cos alpha. So these are the equations. So what I wanted you to be clear is, this seems very simple, but I have observed that students make mistakes here. Be clear about the steps, and it's very simple. Then you will remember, of course, that perpendicular to the inclined plane is mg cos alpha, and along the inclined plane is mg sin alpha. But remember the directions when you take it into the equations. Thank you.